Okay, we're going to do another Excel tutorial here for statistics. This one is one of my favorite riddles of all time, just because it's one thing to say I don't know the solution, or I don't know, how to solve it, but it's another thing entirely to be very emphatic that the solution is something other than the real solution. So this one historically has stumped Nobel laureates and mathematicians and people. It's based on the show Let's Make a Deal, which Monty Hall was the host, and that's why it's called the Monty Hall problem. Traces back to 1959, at least in America, and probably before that in other countries and cultures. So the basic problem is there's 3 doors, and behind one of the doors there's a new car, and behind the other 2 is a pet goat. And you get to have an initial guess of which door you think the car is behind, and then the host, Monty Hall, will open one of the other 2 doors and always show you a goat, and then he offers you the chance to change your guess to the remaining door. And the question is, should you change your guess? Or is it random? And there's multiple ways to solve this using Bayes' theorem or something like that. But we're going to do it using a simulation. So it's an Excel tutorial. So the first thing we need is a column to keep track of how many times we're doing it. And then we'll do, we need a random number generator. So we're going to do basically the odds, a random number generator to find out where is the prize. So it's got to be behind one of these doors, but not more than one. So we can use the number 1, 2, or 3 to designate that. And the way you do that in Excel is equal sign for a function, start typing random, and you can down arrow and then hit tab, and that'll give you the function and the parentheses ready to go. So we want 1, that's the bottom, comma, the top, 3, just hit return, you don't need to close parentheses, and it'll do it for you, 3. So random numbers will, if you double click and then move cells, it will automatically refresh random numbers. Okay, so door 1, what we're going to use here is problems like this. They're binary, whether it's yes or no. Use numbers 1 and 0 because all your probability calculations will be much more convenient. So equals if, then we want if this cell let's try this again. If that equals 1, right? That's the condition. So if that cell equals 1, then we want a 1 to be under this column of door 1. Okay, that means the car is behind door number 1. If it's not equal to 1, then it's a 0, which means the car is not there. Okay. Same thing. So one of the tricks we'll learn here is if I just copied and pasted this like that, right? You highlight the cell, you grab this little box and you drag. This will copy and paste it to all these values. Look at what it does. You always want to verify this because see how it changed from B8? So it's pointing to that cell. And now it's, sorry, I got to undo that because I didn't mean to do that. So this is C8. So it's testing whether door number 1 was the random number generator, but that's not what we want. So instead of changing them all manually, so let's delete this. What you can do is you can put a $sign behind one or both. And so since we're going to be doing this like 10,000 times, we actually want it to stay in the column, but not necessarily on the row. So the dollar sign will lock in the column, and that's the B column. So hit enter, and then you can see if I drag this out, so if B8 equals 1, then it's 1. And then we want this one to be 2, and this one to be 3. Okay, and then what I usually do in these situations is to make sure that this is going to copy down is I highlight the whole row and go down and then just take a look. Random number generator, that looks good. Trial 2. And you can see how that's B9 on this row, so that's correct, right? We want it to stay within the row. The key with these games is making all your data in one row and then simulating it down. So what we want to do is say, there's two scenarios here in this game. You're either going to stay with your original guess, or you're going to switch doors. So I've labeled this, switch or stay. So, switch, stay. Switch. So the hardest part of all these spreadsheets is deciding how to express this algorithm and whether you win or not. So say we're going to say our initial guess is door 1. It doesn't really matter what our initial guess is, right? The statistics should be the same, whether we start on 1, 2, or 3. So say we start on door 1, and this is our guess. Say the car is actually behind door 1. Okay. When the host, and that means there's a goat here and a goat there. So if we guess door 1 and Monty Hall turns over door 2 and we stay, then we would win, right? So we can express that here as equals if door number 1 is 1, in other words, that's the car, then it is a win, which is represented by a 1. If not, it's a 0. So we can test it, right? So let's test it just a few times to see if we've got it right. So if the car's behind door number 1, this is always going to be our initial guess. We're always going to say start with door number 1. Monty Hall shows us door number 2. We stay, we win. Monty Hall shows us door number 3. We stay, we still win. Right? So all we have to do to check is when is the car behind door number 1? There it is. We're going to stay, we win. It's behind door number 1, we stay, and we win. So that's right. That looks good. If we're going to switch, so let's go back to staying. So say we're going to guess number 1. Monty Hall is going to show us door number 3, right? Because that's the one with the goat. If we stay, we're going to lose. Okay, and that's expressed by, say, this one. The prize is behind number 1. We guess number 1. Sorry, the prize is behind the door 2. We guessed number 1. He showed us door 3. We stayed with our original guess, and we lost. Okay? So for switching, you can see that, say we guess number 1 first, right? That's always what we're doing. We're always initially guessing number 1. He shows us number 3. We switch, we win. Okay? Let's say these are reversed. We always guess number 1 first. He shows us number 2. He has to, because that's the only goat left. We switch onto the remaining door, and we win. So basically, the only time we lose is if the car is behind door number 1. Because the car is here, he shows us door number 2, we switch, we lose. If he shows us number 3, we'd switch to number 2 and we'd lose. So the way we can determine whether we won or lost is if door number 1 equals the car, then we'd lose. Otherwise, we'd win. It takes a little bit of thinking through to convince yourself of this, but it's true. There are only 3 doors, so you know, and it becomes clear how you can solve this mathematically using other methods without having to simulate it. But this is, we're going to simulate it so we can convince ourselves. So let's do this 10,000 times, shall we? And I have to figure out a way to make this a shortcut for this. So there's 10,000. 8, 9, 10. 10,000, right? That's our trial number. This is a row number, trial number. And what we want to do is we want to ask ourselves, what is our win percentage? So basically, you know, should you switch or should you stay? Well, the percentage of the time you win if you switch is simply going to be the average of this entire column. And the shortcut to get all of these values is Control Shift down arrow and then hit return. And then for this, it's the same, but with the stay column. So get the open parentheses and then click on the first cell, Control Shift down arrow, then hit return. Because you don't have to close the parentheses, it'll do it automatically. So the reason why we use 1s and 0s is because you can see that if this is a win and a loss, the average of these two is exactly the win percentage. You know, the percentage of the time you're going to get a 1 versus 0. You can think through that a little bit, but it's basically the solution now is so it turns out it's better to switch, which agrees with how you can derive this using statistics. But pretty interesting problem. It's my favorite riddle of all time because so many people get it wrong and are very emphatic that the odds are 50%. One of the ways you can convince yourself is if you had 1,000,000 doors and you picked one door, you know, your odds of picking the right door are 1 in 1,000,000. Well, if I uncovered 999,998 other doors, should you switch? And the answer is clearly yes. Anyway, I hope you enjoyed it.